Welcome, this is our presentation talking about our final project in CSE 6250 Big Data for Health Informatics. The objective or goal of the project is to create a machine learning model that can accurately predict the mortality of a patient using only clinical notes. In the MIMIC3 dataset, the link is provided. Out of 22 tables, we are only using patients and notes events table. For quick prototyping, we decided to leverage Dataiku Data Science Studio, DSS for short. DSS is the collaborative data science software platform for teams of data scientists, data analysts, and engineers to explore, prototype, build, and deliver their own data products more efficiently. We like the ability to code or use one of their pre-existing templates to quickly prototype our pipeline. DSS is a web-based user interface which allows for all of us to work simultaneously. To the right is our pipeline, also known as flows in DSS. For our preliminary data analysis, we use DSS to quickly explore the data to gain better domain knowledge. Out of 46,250 patients, we have a little over 30,000 patients that are alive, which is close to 66% of the total number of patients. 66% is an important number because it serves as a baseline for our models. Essentially, we had a model that predicted false or mortality. We can achieve 66% accuracy. Data cleansing is key to crafting a successful classification model. As they say, garbage in, garbage out. The dataset in Mimic is nicely structured except for text. The new line character breaks import into Hive and Spark data frame. Therefore, we do the following. After data is cleansed, we want to extract features using some common natural language processing techniques. First, we tokenize on whitespace. Remove any words less than 4 characters. This should eliminate punctuations. Remove any stop words, which is provided by the NLTK package in Python, such as is, the, are, basically words that hold little to no important information. We try to include stemming, which allows similar words to be treated similarly, but we later found negative impact. We next use term frequency, which counts the number of words that a note has. To offset the count, we apply inverse document frequency, so words that appear in all of the documents will be weighted lower. An easy way to gain domain knowledge is to use topic modeling. For topic modeling, we use latent Dirichlet allocation, LDA, which is a generative statistical model that allows a set of observations to be explained by unobserved groups that explain why some parts of the data are similar. The bottom two tables show the impact of using stop word removal and filtering out short words, in this case 4 characters. The table to the left shows the top 5 terms that we can't really use, whereas the one to the right has better words. For topic 2, we know is dealing with human heart because of the word aortic ventricular valve. Topic 9 seems to indicate infants and their respiratory system. The data visualization on the right shows a different representation of the tabular data. The bigger the circle, the higher the probability that word belongs to that given topic. For model selection, we use only 10% of the dataset to quickly evaluate which model would perform the best in our binary classification problem. For artificial neural networks, we tune the number of hidden layers. For logistic regression, we tune the regularization L1 or L2 and the parameter C. For random forest, we tuned on the number of trees, max step, minimum number of samples. For K nearest neighbors, we tuned on the parameter K and also the neighbor find algorithm. Our results can be seen in the provided table. We decided to choose logistic regression due to the high recall and fairly quick runtime. Before we apply any updates to feature selection, we want to create a baseline by tuning logistic regression on the full dataset. The best parameter is when C is equal to 1 and using L1 regularization. Our big data pipeline was created in Microsoft Azure's HDN site. The Spark cluster consists of 2 D12 version 2 head nodes at a minimum. The number of workers started at 2, then scaled to 6 to help meet some of our challenges like running LDA. We further tuned the feature selection and logistic regression model using Spark's built-in param grid builder, which allows us to explore the hyperparameter search space. The evaluation criteria is area under the curve. Finally, we get the results. The table shows the various tweaks we did to try to get the best AUC and accuracy. The filtering includes stop word removal terms less than 4 characters, terms that do not show up in at least 6 documents. Adding LDA topic distribution to the features did not help our model. Although the training AUC got 0.89717, the model did poorly on the test dataset. One reason might be some of the nodes in the test set is not accurately clustering the LDA model. Overall, we are happy with the results we got. From hyper-tuning the models and doing some more feature selection, we were able to get a 4% increase in both AUC and accuracy. Thank you for watching, and we hope this can help medical services accurately predict mortality.